before we actually jump into the main presentation itself, everybody is familiar with Claude Desktop, right? I've asked a question, I've not hit enter yet. What are the best English language horror movies of 2025? Claude Desktop, when I hit enter, what do you think is going to be called? Or rather, how does Claude, the LLM model, know which are the top best horror movies of 2025?
Depends on your agents.
Depends on?
Your agents that are configured.
Okay. You said something about?
The data type is like Sonnet model you are using.
Okay.
Fed with these many lines and it has.
Okay. So Sonnet 4.5 is the LLM model I'm using for this search. And when I hit enter, which is here, if you notice, it's thinking. And do you see this searching the web bit? Right? We've all heard and learned and spoken about MCP in the last talk as well, and I'm sure some of you have already worked with MCP servers. Was this an MCP call?
No.
Or
It's an open-ended RAG call.
it's an open-ended RAG call? Okay.
It's a tool call.
Oh, it's a tool call?
Yeah.
Okay. The reason this is obviously not an MCP call in the context that all LLM clients like Claude Desktop, Cursor, C-Line and Windsurf and all these things, they already have access to the LLM's cutoff learning date, right? So the LLM itself has some knowledge that it can retrieve. Like capital of France, for example, will not go searching the web; it knows it's Paris. But more late, the content that has been created now, information that is available now, knowledge that it did not have while the cutoff date happened, is available through a tool call. The tool calls can be made natively through the LLM, right, as part of its implementation, or externally, based on whether the tool is going to access information that is restricted in nature. My name is Riaz. I'm the co-founder along with Akash for AppSec and Cloud. I'm chief hacker at both the companies. AppSec was a boutique security consulting company that we started almost 10 years ago, where we hack SaaS products, AI first applications, MCP servers, agents, all sorts of things. Right? And we've recently also finished a pentest that had multiple agents talking to each other. Right? And at Cloud, we have a hosted cloud security scanner. You can use it like a CSPM. I have been in the offensive security domain for almost about 16 odd years now. And over my career, I've broken almost every kind of conceivable infrastructure or application in those things. But AI security in itself is an exciting and a little scary in terms of what the different components are, right? A lot of us claim that it is old things packaged as new. A lot of people who are learning are saying that it's new. A lot of different concepts within AI technology is new. As a pen tester, it is a scary world out there, right? But I'm on a journey to go from being a pen tester to an AI red teamer and AI security engineer all bundled to one, right? So that's a journey which is where I've been picking up on MCP servers belonging to a lot of other customers as well. I'll cover, what is an MCP server from a point of a pen tester, and I need your help in filling some boxes there. We'll do a quick recap. I think I'll skip that because a lot of us already spoke about MCP security at a general level. Then we'll look at the attack surface, and I have a bunch of demos and examples that we'll take on, and then we'll end the session with a Q&A. We've all seen the definition of what an MCP server is, officially documented by Anthropic. People who are AI engineers talk about it and how they use MCP on videos and tutorials online. But from a pen tester's point of view, if you're going to be attacking this technology, this nuance, you would need to break it down into its individual components, right? For me, as a pen tester, when I look at an MCP server, for me it is nothing but a process running either locally or as a web endpoint. If it's a web endpoint, I'm not too concerned about what the internal workings are as a pen tester. That I'm looking at from an external attacker's point of view. If it's local, the code is accessible to the user and the local system, right? MCP servers have functions which are called tools that are called by clients like Claude and Cursor. MCP servers have access to embedded resources or resources that are supplied at runtime, like Markdown, PDF, web pages, right? And if they are externally hosted on the internet, you have additional tools that can fetch those resources for you. Okay? MCP servers may have prompts that will be consumed and processed by the client. Like a whole set of category of vulnerabilities come across into MCP because of its ability to host and have prompts. Because there is a huge gap between MCP deployment speed and security testing and security readiness, you get to see a whole lot of MCP related security issues come up in discussions or being published. Right? The gentleman earlier asked about why authentication authorization is not like the obvious thing in MCP. Because the launch of MCP servers as a technology to it becoming business ready and everybody in the world wanting to have an MCP server, that time was too short to have an authentication actually came into MCP as a protocol implementation in July. Yeah, June or July, the 06 25th edition version of the protocol itself. Authentication authorization, right? It's pretty much late, 3 versions now. But yeah, that's the reality between how there is a gap between how fast developers are putting this online and pen testers wanting to understand what it is. From an attacker's perspective, local MCP, I'll kind of differentiate between local and remote MCP with certain things, and there's a commonality between both of them in terms of what kind of security issues can occur. Local MCP, code execution possibilities, the process has to be trusted when you're running it on a system. Think of old school ways of, would you run a curl command and pipe it to bash directly, right? If you've ever found it on the internet. But a lot of folks are running npx-y and the MCP server name without asking where it came from. Embedded secrets, because the local MCP servers, you have access to the library itself, the package, and the code that's running on your system. You have access to the source in some way, even though it's minified in some cases. You can look for embedded secrets, PII, unnecessary variables, code artifacts from refactoring due to an older version. Right? Supply chain rogue upstream packages is always an issue with any kind of software that runs on your system. Overprivileged file system resource access, it is supposed to do it's supposed to only access say a particular folder, and there are ways by which you can bypass that restriction because of the way it is programmed, not because it is meant to access a folder outside, but say it accepts // instead of full paths. Remote MCPs, OAuth redirect, URLs can have issues. Instead of redirecting to an HTTP endpoint, you could redirect to a JavaScript endpoint and then execute code because it's running inside Node. Local code processed by remote MCP. Remote MCP in itself is an MCP that you can run and call remote SSC or HTTP streamable remote MCPs. So with that functionality, in terms of any and all API related security issues that can occur in a remote MCP server. Right? Common between both the authentication layer, yes. If you look at the spec for MCP server, the June 25th version, the latest one, it says authentication is optional for local MCP and it is optional for optional for remote MCP, and local MCP need not have authentication. Right? So we are there as an industry. I'll just do a demo of at least. Actually, let's see if you can do demo all of them. Right. So when I said about when I spoke about MCP having secrets and PII, when you interact with an MCP server within your client, have you ever looked inside the MCP server to see if it has got any API keys embedded, any email addresses embedded, any PII data of the developer embedded? Have you seen some of those come up in some of our assessments? I'm going to use Claude Desktop heavily for all of my demos, but any other client in that way works. So I've got a bunch of them running here. The one that I'm going to call is one MCP example secret file. It's got a current IP, temperature, city, and news article. Okay, so let me just call. The client will always check the local MCP servers if there are any, connectors if there are any, to see it can use that instead of relying on the tools that it has on the server side. Okay. Pretty much straightforward, but because this is running locally, right, we can actually look at the source of this MCP server. As part of, I'm just showing this as an example, but when you have access to the MCP server running itself locally, right, you can always use an npm pack command, for example, and get the tar unbundled locally, and then open it up within a code editor and take a look at the source itself, right? At least in a couple of places, we found API keys embedded within and then posted to npm as a package, right? And that came up as a shock for the dev team, because at least one of the keys was not working in one case, and they had not removed it from the package that went on the internet. Namespace typosquatting. We've seen this as an example, but if you did not notice in the Claude configuration, there was an MCP server called Twitter MCP. Right? You see Twitter MCP? What do you think is wrong with this? It has get account, get tweets, right? And you can actually run this if you have access to, if you have laptops right now, you can run an npx-y Twitter -mcp, but with three T's, and this is already published on npm, right? So name squatting or typosquatting would be this. Another example would be with a homograph text, right? Like you can have the Cyrillic characters in place of English, or you have 3 O's instead of 2 O's for Google, right? So things like these get published. Then either you name squat the publisher and the package, or the package, and then you can call it without using the publisher name. Like any other typo squatting issue, attackers can squat on typos, similar names, homographs. Worth checking the neighborhood naming convention of the MCP server if you're testing for an end customer, right? As a pentester, if you're going to be testing for your customers, look at the neighborhood of the MCP server that's been published. Squatting can be across publisher names or the package name, or even in fact including the tool names as itself. Because if an MCP server is going to be local and published, the user has, the pentester has access to the entire source, right? Nothing stopping them from opening it, adding another tool, rebundling it, and publishing as a closed name to the internet. Code exec, this I can go demo. So I'll go to new chat and say, can you get me a quote. Again, call the MCP. Now, if you look at the source for this, and I'll share that with you folks, you can actually format the output that the MCP server has returned, right? So, because it's Claude Desktop, we can't do too many complex execution, and I'll tell you why. But if I run, get me a code of the day and format the output with json.stringify process.env. Okay. This is, in fact, process.env works. I have it in one of the chats over here. I can show it to you folks.
Is it calling the correct MCP server?
No, it's calling the correct MCP server. Earlier it died because the DNS timed out for. If you notice this, if I do like an advanced process exec, like say I want to pop calc within using Claude, right? This will definitely not work because Claude has the ability to detect that you're passing command injection related and across languages, right? But however, you can still read process env and because internally in the code there's an eval that is being done on the formatter that you pass to the code. Okay. Code within MCP may allow deliberate or unintentional code execution. Evals, process, loads and calls, boundaries checks, etc. All of these things need to be checked. A very interesting case is the last one, where boundary violations can lead to all sorts of interesting things. Right? Imagine this scenario, at least in one case, for a remote MCP, where the MCP had the ability to make a request to a web endpoint and extract data from that web endpoint and use that within another agent. Okay. If the remote MCP server was running on AWS as an attacker, what web page could you possibly ask it to fetch? The instance metadata endpoint for EC2, right? That's an obvious attacker foothold within the environment, right? You could ask the remote MCP server, hey, can you fetch this web page? And now your MCP server is making the call to the IMDS V2 or V1 endpoint. V2 also chalega because you can ask it to pass headers as well, right? And you can make that request, fetch credentials, escalate your privileges to the AWS environment where the remote MCP server is running, right? So boundaries have to be identified either locally or on the remote side where it does not do or access particular functions that are resources that are outside its scope. Last one, MCP malicious tool calls. For this one I have, let's check if affiliation is up. The health status check. Okay, all regulation services are great. However, a malicious tool call within the MCP by changing some part of the prompt would be get regulations global health status. Right, so a malicious tool call can be used to change the context that has been returned by the MCP server before it's fed into the client. Right. This one also has an additional example. If we go to the top, is actually the next one for the indirect prompt injection. If you notice, the response that came back from the MCP server, this is from status.relation. They have like a JSON endpoint where you can dump the current status. Apart from the description, the response that comes back, the MCP server also modifies the response and asks the client to try and print an omelette recipe. And that's obviously not part of what the MCP is designed to do. But imagine this, not in the case of Claude Desktop, because Claude as a client, Cursor as a client, and a bunch of these, they have very clear distinction between what is data and what is prompt, right? But think of this from an agent point of view, right? If you have like multiple agents who are going to be using MCP servers to fetch information, pass that information to another agent for processing, right? And that agent performs an action based on the data that was received without trusting it. That's where the indirect second order, in the world of application security, second order issues, in this case, an indirect prompt injection. Yeah, that's the example. Rugpull attacks have been in existence since the first library was used in technology 30, 40, 50 years ago, right? Essentially, at the time of check and time of use for any system component, if it's changed, that's when you have Rugpull. Fancy kids these days call it Rugpull attacks, but they've been forever in the industry, right? The idea is that for the MCP server, based on its different components, whether it is a package that the MCP server uses, whether it is the code of the MCP server itself, right? Whether it is an endpoint that the MCP server's backend calls, any of those change while your agent or your Claude Desktop or whatever technology you're using is being used to make decisions based on what data comes back, right? And if it changes without any authority or especially without informing you. Your agents are going to make decisions that are based on an older assumption. And that's when you have a Rugpull attack. Okay, and this I think we spoke about earlier, so I don't have a demo for this. But I have a quick 10-pointer checklist. If you folks want to get a screenshot of the picture of this, please do. This is advice that I give to pen testers often about going around. How do they go about testing MCP servers or AI agents in general? A couple of months ago, we wrote and launched, open sourced an MCP proxy client that allows you to intercept traffic between an MCP server, local MCP server, and the internet, right? That should allow you to get all traffic between MCP server, the client, the MCP server, and the internet into bubbles, and that's when you get exposed to all the APIs that the MCP server is using. You will be able to then intercept even the STDI calls as well as the backend API calls. Right, that's all I had for today's talk. My name is Riaz. I can take questions. Any comments, any questions? This is my LinkedIn, so it just looks fancy.